Hey everyone, welcome back. Today I'm going to show you how to install n8n using Docker completely free and then take it to the next level by supercharging AI agents with MCP Model Context Protocol. Imagine this. Your AI instantly connects to any tool or API. No messy HTTP requests. No endless API docs, just pure automation magic. That's exactly what MCP does. It standardizes tool execution, making automation faster, smarter, and 10x easier. Here's what you'll master in just a few minutes. Install n8n locally using Docker so you can use it completely free. Set up MCP in n8n to unlock powerful AI automation. Enable AI to find and execute the best tool dynamically. No hard coding needed. Automate web searches and web scraping effortlessly using MCP. And here's the kicker. Stick around till the end because I'll be revealing a secret automation trick that even experienced AI engineers don't know yet. Smash that like button, subscribe, and turn on the bell icon so you never miss an automation hack. Before we set up n8n, let's quickly understand what Docker is and why it's a game changer for automation. Think of Docker as a virtual container system for apps. Instead of installing software directly on your computer, Docker lets you run applications in isolated, self-contained environments called containers. This means no messy installations, no dependency conflicts, and no worrying about breaking your system. With Docker, we can run n8n in a lightweight, portable, and secure environment, making it super easy to set up and manage. Now that we know why Docker is amazing, let's install Docker Desktop. Go to the official Docker website. Download the version for your operating system, Windows or Mac. Run the installer and follow the simple on-screen instructions. Once installed, open Docker Desktop and make sure it's running before moving forward. Now that we have Docker Desktop running, let's pull down the n8n image and set up our AI automation environment. In Docker Desktop, go to the search box at the top, type n8n, and select the official n8n image from the list. Click Download to pull the latest n8n image, so wait for the download to complete. It may take a few moments depending on your internet speed. Now that we have the image, let's create a new container. Next, go to the Images tab in Docker Desktop, find the n8n image and click the Run button. Now, let's configure it before we start. Give your container a meaningful name. Let's call it n8n container. We need to specify a port so we can access n8n via a browser. Set it to 5678 or any other number you prefer so we can access n8n on that port. To ensure that our workflows and user settings are saved, we need to configure a volume. In the volume section, set the host path to a local folder where you want to store n8n's data. For the container path, set it to this path. Since we want to use AI agents with MCP in n8n, we need to update the environment variables. We will need to add this variable. Set the value to true to enable community nodes as tools inside n8n. Once everything is set up, click the Run button to start the container. Give it a few seconds to initialize. Now, let's check if it's working. Open your browser and go to localhost on the port we just set up. You should now see the n8n sign up screen. Let's create an account, fill in all the necessary details, including your username, email, and password. Follow the instructions to set up a new account. Now, click on this button to start a new workflow. Awesome! n8n is now fully set up and ready to use. Next, let's install MCP servers inside n8n. This will allow our AI agents to interact seamlessly with external tools and data sources. Navigate to the Settings section. Go to the Community Nodes tab. Here, let's search for n8n nodes MCP. Then click Install and wait for the installation to complete. Once installed, you'll have access to MCP functionalities within your workflows. Return to the Workflow section and name your workflow. Let's say MCP Server Agent. Okay, next, to initiate our workflow based on user chat input, we'll add a chat trigger node. Alright, now we're going to add an AI agent node to the workflow. After receiving the user's chat message, this node enables the agent to utilize external tools and APIs to perform actions and retrieve information. Now let's configure the AI agent node to use the OpenAI chat model. To use the model, you should create a new credential here. Ensure you have an OpenAI account and have generated an API key from the OpenAI website here, then input your OpenAI API key into the node's credentials and hit Save button. We leave the desired model as GPT-4o Mini. To allow our agent to retain conversational context, we'll incorporate a simple memory node. So let's add the simple memory node to the workflow and connect it appropriately. Now, let's empower our AI agent by integrating Model Context Protocol servers, providing it with robust tools for complex tasks. First of all, we'll add the MCP client to see how it works. There's a list of actions here. Let's try using this action to list the available tools. Next, we need to add credentials to connect to the MCP server. Here, we're using the command line to integrate an MCP server with npx in the command field. The arguments will include the MCP server name. To explore available MCP servers, we'll visit their GitHub page where we can see all the server tools available for our workflow. For this example, we'll use the Brave Search server, which allows us to search for businesses, restaurants, and services with detailed information. To use this MCP Brave server, we need an API key from the Brave Search API. So let's create a new account to obtain the key and copy it for later use. Next, we'll add the MCP server name to the argument field and input the Brave API key. Alright, finally, we need to update the environment with the Brave API key. Fill in the Brave API key we just copied. After hitting Save, we specify the action List Tools for the operation. Now we can test this node to retrieve the available Brave tools. We have 2 Brave tools here, along with their capabilities. Awesome! Now that we know how to use the MCP node in n8n, let's add an MCP server as a tool for the AI agent. We'll remove the current MCP example, click the plus icon to add a new node for the agent, and select the MCP client to fetch a list of Brave tools. Make sure to choose the credentials we just created. Finally, we add another MCP node to allow the agent to execute the tools. Configure the AI agent to utilize the tools retrieved from the Brave Search MCP server. Set the operation to execute tool and specify the tool name obtained from the previous MCP node's tools. Configure the tool parameters as needed or allow the model to define them automatically. Before running the workflow, let's define a system message to guide the AI agent in its role, such as, "You are a helpful assistant utilizing Brave Search to perform web queries." Alternatively, you can use our system message. Next, ensure all nodes are properly connected to facilitate smooth data flow and execution within the workflow. Once everything is set, we're ready to test the workflow. Open the chat box and send a message asking the agent about restaurants or cafes. Monitor the workflow execution to make sure the AI agent interacts with the MCP server as expected. Let's dive into how our AI agent processes user inputs. Initially, the agent captures both the user's message and the predefined system instructions, storing them in the simple memory node. This ensures context is maintained throughout the interaction. The stored messages are then forwarded to the OpenAI chat model node. Here, the AI interprets the user's request and determines that utilizing the Brave Search tool is the optimal approach to fulfill the task. The AI agent employs the MCP client node to interface with the Brave Search MCP server. It performs the necessary search operations based on the user's query. After obtaining the search results, the OpenAI chat model processes the data, transforming it into a coherent and informative response tailored for the user. Finally, the AI agent delivers the human-readable information back to the user, effectively completing the workflow. Awesome! By integrating MCP servers like Brave Search into our n8n workflows, we've empowered our AI agents to perform complex tasks efficiently, providing users with accurate and timely information. Stay tuned for more tutorials on enhancing your automation workflows. If you found this guide helpful, subscribe, and hit the notification bell to stay updated with the latest automation tips. See you in the next video. Hey everyone, welcome back. Last time, we showed how to use the Brave Search server through MCP to quickly build a powerful search tool in n8n. But today, we're about to unlock something even more exciting. Imagine being able to instruct an AI agent to do complex tasks on the web just by describing them in plain English. That's the power of MCP server. We're going to use MCP Firecrawl, a way to turn plain English into fully automated web crawling tasks. Normally, if you want to scrape or analyze a website with Firecrawl, you need to deal with APIs, set up complex parameters, format requests, and handle all the technical details. I'll even show you a bit of that API documentation, just to see how complex it can get. But with MCP, you don't need to write a single line of API code. Instead of wrestling with code and API setups, you just tell the agent what you need. Something like, visit this website and summarize the latest 3 blog posts. That's it. The agent takes care of everything behind the scenes, handling the complex steps, making the requests, and returning exactly what you want. The MCP server takes that natural language prompt and figures out how to call Firecrawl behind the scenes. It simplifies the whole process. No tokens, no endpoints, no JSON, just results. So in this video, I'll walk you through how to build an AI agent in n8n that uses MCP Firecrawl to browse and extract data from the web without writing any API logic. Now let's dive into another fantastic example of MCP Firecrawl in action. Scraping trending e-commerce products for affiliate marketing. Imagine you want to target products that are emerging in popularity, perfect for affiliate promotion. You simply provide a prompt like scrape trending products from website and let it work its magic. The MCP Firecrawl automatically navigates to the site, scrapes and collects all the relevant product information, and even filters out the items that are currently trending. It's literally as simple as text in, results out, just like the video thumbnail shows. This means that with just a single prompt, you get all the data you need to identify high-potential affiliate products without any manual hassle. Let's dive in and see how simple it can be. Now that we have a basic understanding of the changes, we're going to duplicate the last workflow and give it a new name, MCP Firecrawl. We'll still be using the ChatGPT model as the large language model for the AI agent. Remember to choose the right credential that includes your OpenAI key, as we'll still be using this simple memory setup that lets the agent maintain and remember the conversation. Now, about the AI agent tool. Instead of using the Brave Search server to search for things we're interested in, we're now going to use another powerful server called MCP Firecrawl server. This allows us to scrape any content from any website with just a few words. So let's remove the Brave Search server from the workflow, and we're going to rebuild the MCP client to connect to the MCP Firecrawl server. As usual, let's add an MCP client to the canvas, then connect it to the MCP server we want to test. To use MCP Firecrawl, we'll need to add a credential for this MCP client. Just like with any MCP server, the easiest way is to use the command line to specify the MCP server we want to connect to. So we'll add the MCP server name here. Okay, now we need to create an account, generate an API key on the Firecrawl official website, and fill in the details here. It's completely free, so don't worry about any costs. Alright, Give this node a name. Once done, we can test the node to see the list of tools that the AI agent node can use to implement the task. Alright, look at all the useful tools we can use to scrape websites. Firecrawl allows us to scrape a single web page with advanced options for content extraction, scrape multiple URLs or pages, extract structured information from web pages using an LLM, even conduct deep research on a query using web crawling, search, and AI analysis. Very powerful. Imagine you can schedule a task every day to extract and conduct deep research on multiple websites. Get the content you're interested in and summarize it to have the best resources then sent to your email or Telegram account. Pretty awesome. Next, we're going to add this MCP client as a tool for the AI agent node. The easiest way to do this is by removing the current test node, then clicking on the plus button to connect a new node to the AI agent tool. Once we get the list of Firecrawl tools, we'll use another MCP server to execute the tasks. So let's add a new MCP client as a tool here. The operation here will be execute tool and we'll describe the tool name like this. Essentially, we're telling the MCP Firecrawl node to pick the appropriate tool from the list of tools that the previous MCP node returned. Configure the tool parameters as needed or allow the model to define them automatically. Make sure to choose the credential we just created for Firecrawl. Alright, let's give it a meaningful name. To keep things consistent, let's also rename the first MCP client to Firecrawl List Tools. Awesome. Now, let's instruct the AI agent node to use MCP Firecrawl to scrape a website. First, we'll run the list tools MCP node to get a list of the current available tools. Then, we'll tell the second MCP client, which acts as the execute tool action, to pick one of the tools from the previous node in order to answer the user's question. We lay out our nodes a bit to make it cleaner. This helps improve readability and overall structure. Finally, let's test the workflow. We'll send a message to the agent asking it to visit a website and summarize the latest 5 blog posts. As usual, the AI agent will use the OpenAI chat model as the interface to communicate with the users. Behind the scenes, it will ask the MCP Firecrawl to list the available tools, then pick one of them to execute the task. Once it gets the result, the OpenAI chat model will automatically format the results and make them human-readable for the user. Awesome. And that's it. We've successfully built an AI agent in n8n using the MCP Firecrawl server to scrape websites with ease, all by simply describing the task in plain English. No complex API calls, no coding, just powerful automated web scraping using MCP. You can now automate the process of pulling data from websites, summarizing it, and even sending it to your email or other platforms without lifting a finger. This opens up so many possibilities for automating research, tracking content, and much more. Remember, the MCP server makes this whole process so much easier by abstracting away all the technical complexity and allowing you to focus on what matters most, getting results fast. If you found this video helpful, don't forget to like, comment, and subscribe for more automation tutorials. I'd love to hear how you plan to use MCP Firecrawl in your own workflows, so feel free to share your ideas in the comments. In the next video, we'll dive deeper into more advanced AI agent workflows. You won't want to miss it. Thanks for watching, and I'll see you in the next one. Tired of paying monthly fees just to use AI LLM models like OpenAI chat model in your automations? What if I told you you could run powerful AI models like DeepSeek or Llama right on your own computer, no API keys, no subscriptions, completely free? In this video, I'll walk you through how to set it all up. We'll install a local LLM, connect it to n8n, and replace the OpenAI chat node. saving you money and gaining full control over your AI. To run LLMs locally, we'll use a powerful desktop app called LM Studio. Think of LM Studio like a launchpad. It lets you download, run, and chat with large language models on your own machine without the cloud. Whether you're on Windows, Mac OS, or Linux, just head over to LM Studio and download the version for your operating system. Once installed, open LM Studio and you'll see a clean chat-style interface. This is where you can interact directly with any local model you download. But before we can chat, we need to load in a model, and that's where the Discover tab comes in. In the Discover section, you'll find a library of open source LLMs like DeepSeek, Llama, Mistral, and more. Each model has its own strengths, but for this video, we're going to use DeepSeek, which is optimized for code and reasoning tasks, perfect for workflow automation. Click on the DeepSeek model for good performance on most machines, and start the download. Once the model finishes downloading, it'll appear in the My Models tab. This is your personal library. Any model you've downloaded will live here, ready to launch at any time. Now, let's go back to the Chat tab, select DeepSeek, and try it out. With DeepSeek selected, go ahead and type your first prompt, just like you would with ChatGPT. The response time depends on your system. If you have a decent GPU, it can be surprisingly fast. And just like that, you're chatting with an AI model that's running entirely on your computer. And more importantly, it's completely free. Now, here's where the magic happens. LM Studio doesn't just let you chat with a local model, it also starts a local API server in the background. That means you can connect this model to other tools, like n8n or any other cloud provider. But before we can connect it, let's make sure the server is actually running. Head over to the Developer tab in LM Studio and check the server status. You should see something like HTTP server listening on port 1234. Now let's take it a step further. Copy this URL and paste it into your browser. Here, you'll see all the models currently loaded and available to serve requests. If your model, like DeepSeek, shows up here, it means the backend is live and ready to connect with n8n. So far, so good. Now let's jump into n8n and wire this up. With our local server running and the DeepSeek model active, it's time to replace the paid OpenAI chat node inside n8n. Wherever you're currently using the OpenAI chat node and open it up. Normally, this node sends your prompts to OpenAI's cloud using an API key. And that's what costs you tokens or monthly fees. But we're going to rewrite this, so instead of OpenAI, it will send the request to your own local server running right on your computer. First, we need to create a new API credential. But don't worry, since we're using a local server, we don't actually need a real API key. Just enter anything, even a random string like ABC123, it won't be used. Give this credential a clear name like DeepSeek model so you can easily find it later. Next, scroll down to the base URL field. This is where we tell n8n where to send the request. Instead of OpenAI's official API URL, paste in the address from LM Studio, which is localhost, on port 1234. This tells n8n, hey, send this prompt to the local server instead, and let DeepSeek handle the response. Alright, now that everything is configured, the credentials are set, the base URL points to your local server, and the model name matches. It's time to test the connection. Open the chat message field and write a simple prompt like, hey, then click send. And here we go. We get an error that says something like request to localhost was refused. Don't panic, this is expected, especially if you're running n8n inside Docker. So why does localhost work in your browser, but not in Docker? Here's the key. When you open a web browser on your machine and go to localhost on port 1234, you're telling your host operating system to look for something running on your own computer. And LM Studio is running there. So it works. But when Docker sees localhost, it's doing something completely different. When you're running n8n in a Docker container, the term localhost refers to inside the container itself, not your actual computer. So when the chat model of a n8n workflow tries to call the local host on port 1234, it's essentially saying, "Hey Docker container, do you have a server running on port 1234? But of course, there isn't. The LM Studio server is running on your host machine outside of Docker. That's why you're seeing this connection error. It's Docker trying to talk to itself and failing. That's where Docker host internal comes in. It's a special host name that tells Docker reach outside the container and connect to the host machine. So when you change your base URL from localhost to host.docker.internal, it correctly routes the request to LM Studio running on your actual computer. Nice. The connection test was successful. That means n8n is now able to detect all the models currently available in LM Studio, including the ones you downloaded to your machine. In the drop-down list, you should now see DeepSeek along with any other models you've added. Go ahead and select the DeepSeek model from the list. Also change this node to DeepSeek Chat Model. Before we run the final test, let's clean up the workflow canvas a bit. If you've got extra or unused nodes from testing earlier, feel free to delete those to keep things tidy. A clean workspace just makes it easier to debug and extend your automation later. Now for the moment of truth. Open the chat box and send a simple prompt and give it a moment to respond. And boom, it works. You've just sent a message to a powerful LLM running locally inside a no-code automation platform. So, what did we just accomplish? We installed LM Studio and set up a local API server. We downloaded and ran the DeepSeek LLM on our own machine. We connected that local model directly to n8n, replacing the OpenAI chat node, and we successfully sent a test prompt and got a live response, without using the cloud, without paying a cent. This setup gives you full control over your AI workflows, local, private, and cost-free. And this is just the beginning. If you found this useful, hit that like button to let the algorithm know. Subscribe if you're building AI-powered automations and want to stay in full control. And if you ran into any issues, drop a comment below. I read every single one. See you in the next one. Hey guys, welcome back. So you've got n8n running locally in Docker, maybe even integrated with free LLMs like DeepSeek or Llama that's already powerful. But there's a major limitation right now. You can only access your workflows through localhost. That means only your machine can run or trigger them. You can't share workflows, trigger them from another device, or integrate with tools like Telegram, Gmail, YouTube, or Stripe because those platforms require URLs served from a domain. Sometimes they specifically need a public webhook URL tied to a valid domain, and localhost just won't cut it. So how do we take this local setup and upgrade it to production level without paying for a domain or cloud server? So why we need a domain? Most cloud services like Google, Facebook, or Stripe expect your app to have a public domain like abc.com or n8n.com. So if you want to integrate those services into your workflows, you usually need to buy or own a domain. They don't accept raw IPs or local host addresses. That's why hosted platforms like n8n Cloud give you a subdomain automatically. But buying a domain and setting up DNS isn't beginner friendly, and it adds cost. So in this video, we're going to do the same thing, but free, using ngrok, a tool that gives you a public HTTPS domain and tunnels it directly to your local server. Let's dive in and turn your local n8n setup into a secure production-ready environment without spending a dime. But before we get started, I've got something special for you that can take your learning to the next level. We've just launched a free community on School designed for automation enthusiasts, no-code builders, and AI explorers like you. It's called Zero to Launch AI Automation Community, the most up-to-date space where the latest AI and trends become real, explained in the same clear, intuitive way you see in my videos. And here's what makes it different. Get your questions answered faster with full threads, screenshots, and community discussions that go way deeper than a reply on a YouTube comment ever could. You'll get instant access to the templates I use in my YouTube tutorials, along with other future workflows and resources. These help you save countless hours and let you build without starting from scratch. You can join the Zero2 Launch community right now using the link in the description. It's completely free. Alright, let's jump back in and get your n8n setup ready for production. Like I mentioned earlier, we're going to use ngrok to expose our local n8n server to the internet. But what exactly is ngrok and why do we need it? ngrok is a tunneling service that makes your local server accessible from anywhere on the internet, securely and for free. Here's what it does. It gives you a free public domain. It creates a secure tunnel from your machine to the web, and it automatically enables HTTPS, which is required by most APIs and platforms like Telegram, Stripe, or Google. You can build and test production-grade workflows from your laptop. No cloud server, no domain purchase needed. Now that you know what ngrok is, let's set it up. Go to ngrok.com and sign up for a free account. Once you're in, you'll land on your ngrok dashboard. It will walk you through how to install ngrok on your machine and deploy your local server to the internet using a secure public domain. Now let's install ngrok on your machine. Either follow the CLI instructions or just download and unzip it directly. Super simple. After successfully downloading and unzipping ngrok, we're almost ready to go live. But first, we need to update our n8n Docker container to work with the new public domain. And don't worry, we'll do this without losing any of your workflows, credentials, or data. Now it's time to upgrade your n8n container setup so it can communicate with the outside world through ngrok. Head back to Docker Desktop, and here's what we'll do. Stop and remove the old container. Reuse the same volume or bind mount for the data folder. Launch a new container with updated environment variables, including your ngrok domain. This will keep your data safe while unlocking secure public access to your workflows. Alright, let's go ahead and launch a new container using the n8n image. This time with updated environment variables, including the ngrok domain we'll use to expose our local server to the internet. As usual, we'll start by giving our container a name and assigning a random number for the port. This keeps it separate from any other containers we might be running. Now, here's an important part. When setting up the volumes, we need to make sure we use the same n8n data folder from the previous container we deleted earlier. This is how we make sure none of your workflows, credentials, or execution history get lost. The container path will still be like this. That's the default path Docker uses to store n8n's container data internally. So essentially, the container path is automatically mapped 1-1 to the host path, which is the n8n data folder we just configured. To put it simply, the host path is the folder on your computer, where you can browse and manage n8n data directly. The container path is where n8n stores that data inside Docker. And because they're linked, both paths will always reflect the same data. So even if you delete or recreate the container, your workflows, credentials, and settings will stay intact, as long as the host path stays the same. Now let's move on to the environment variables. This is where we unlock all the important capabilities. First, we'll add the variable that allows n8n to install and manage community nodes, like the MCP nodes or any custom packages you might want to use later, just like we did before. Next, we need to set the n8n editor base URL. This defines the main access point for the n8n front end. Basically, it's the public URL that the editor interface will use. Instead of accessing it through localhost like before, we'll now use a static domain from ngrok, so we can access n8n from any device, anywhere. Alright, let's head over to ngrok. Open the dashboard and claim a domain. Once that's done, we copy the public URL ngrok gives us, and we'll set that as the value for our n8n editor base URL. Make sure to include HTTPS, because ngrok gives us a secure HTTPS domain, and that's required for most third-party integrations to work properly. Now for the next critical part, we need to set the webhook URL. And here we'll use the exact same value as the editor base URL. So what is the webhook URL and why is it important? A webhook is simply a way for another service, like Telegram, Stripe, or Google, to notify your server in real time when something happens. A user sends a message to your Telegram bot. A payment is completed in Stripe. A YouTube comment gets posted. All of these events rely on a webhook URL, a public, secure address that those services can use to send data to n8n. So by setting the webhook URL to your ngrok domain, you're telling services like, hey Telegram, hey Google, here's my webhook. Anytime something happens, notify me here. And that's how n8n can process these events immediately and automatically. Finally, we'll add one last environment variable, n8n default binary data mode. Set this to file system. This setting controls how n8n handles large files, like PDFs, images, or videos, which are treated and stored as binary data during workflow execution. By default, n8n stores these files in memory. We mean your computer's RAM, the short-term memory your system uses to run apps quickly. But when files get large, keeping them all in RAM can slow things down or even crash your container. So instead, we switch to file system mode, which tells n8n, don't store binary files like images, audio, and memory. Save them temporarily to the disk. This helps improve performance and stability, especially when working with large file uploads or processing heavy data. It reduces memory usage. But just to be clear, n8n will still use memory to load node packages and workflow execution data. So make sure your system has enough RAM to handle that too. This is a recommended best practice for most self-hosted setups, especially if you plan to run larger workflows or integrate with file-heavy apps like Gmail, Dropbox, or scraping tasks. Next, hit the Run button to start creating the new n8n container. Give it a moment, and once it starts, you should see the ngrok URL appear directly in the container terminal. That means everything was set up correctly. The container is running, the environment variables were applied, and your ngrok domain is now securely pointing to your local host, specifically on port 555 or whichever port you configured. Alright, before we test the ngrok URL, let's quickly confirm that the new n8n container is still using the same data from the one we deleted earlier. Open your browser and go to localhost on port 555. Log in with your credentials, and if everything's connected correctly, you should see all your previous workflows. Awesome. That confirms our volume mapping worked perfectly. No data lost, no setup redone. Next, let's go ahead and test the ngrok public URL. Alright, it looks like the URL says offline. That's expected. Why? Because right now, ngrok and your local machine are not fully connected. ngrok needs a way to authenticate your machine and link it to your ngrok account. To do that, we need to add your ngrok auth token to your local computer. This token acts like a password. It tells ngrok, hey, this domain belongs to me. Let me use my public domain to expose my local server securely. Let's go ahead and run the command that does this. First, open your terminal and navigate to the folder where you downloaded and unzipped ngrok. If you're on Mac, just use the built-in terminal app. If you're on Windows, you can use the Windows terminal or command prompt. The commands will be mostly the same. Alright, head back to the terminal, use these basic commands to check where you are, and move into the ngrok directory. Once you're inside the folder where ngrok is located, you're ready to run the auth token command. If you're on Windows, you can copy and run the command. If you're on Mac or Linux, make sure to add // before ngrok. This command will automatically add your token to a config file called ngrok.yml, which is stored in your local system. If you're curious, you can open this file and confirm it contains the token you got from your ngrok dashboard. Now your local machine knows your public domain, and ngrok is officially authorized to connect it. Alright, now your local machine knows your public domain and ngrok is officially authorized to connect it. Now let's do the final step. actually turning on the tunnel to bring your local n8n server online. We'll do that by running this command. Replace the default port with the port your n8n container is running on, which is 5555. This tells ngrok to map your secure public domain to your local server running on port 555. Awesome. We've now successfully deployed our self-hosted n8n instance to the internet using ngrok. You can now access your n8n editor from any device using this public URL. Trigger webhooks from services like Telegram, Stripe, or Google, and run your automations in production mode, securely and for free. From local to production, without the cost. And there you have it. We started with a simple local n8n setup. Locked behind localhost, and step by step, we turned it into a production-ready automation platform, live on the internet, using Docker and ngrok. You didn't need to buy a domain. You didn't need a cloud server. You didn't lose any of your workflows or credentials. And now, you can trigger webhooks, run workflows, and access your automation dashboard from anywhere, securely, just like with an n8n cloud subscription, but without the monthly fee. This is the power of self-hosting. Full control, zero cost, and endless possibilities. Also, don't forget to join the 02 Launch No-Code AI automation community using the link in the description. If you found this helpful, hit that like button, subscribe for more No-Code Plus AI content, and drop a comment below to let me know what you're building next. I'd love to hear it. Let's keep automating, and I'll see you in the next one. In the last video, we showed you how to run n8n locally using Docker for free. It works great if you keep your computer on 24/7, since all your workflow data is stored right on your machine. But if you're relying on your desktop to host n8n full-time, it's not the most reliable or cost-effective solution. You need to keep both Docker and ngrok running non-stop. In the US, that could add $10 to $30 a month just in electricity, plus $40 to $100 for your internet bill. And let's be honest, your computer might reboot or shut down at the worst time. Not ideal for production. So in this video, we're going to take it up a notch and move n8n to a cloud VPS that runs 24/7 for less than $5 a month. Before we jump into the setup, quick heads up. If you're into building with n8n, AI agents, or automation tools, you'll definitely want to check out my 02 Launch community. It's a free space I built on School for people who want to go from zero to launching real automations. Whether you're just starting or already building advanced workflows, you'll get step-by-step AI automation tutorials, pre-built templates from videos like this one, and real support from real builders. Plus, every resource I mention in this video, including the scripts, links, and tools, will be posted directly inside the community. If you've ever said, just explain this stuff like I'm 5, you're gonna love it. Come introduce yourself, ask questions, and grab the tools you need to build smarter and faster. Links in the description. Alright, back to the setup. Let's explore some affordable VPS providers you can use to host n8n on a budget. First up is OVH Cloud. They offer a VPS starting at just $1 per month. One of the lowest prices out there. For that, you get 1 VPS CPU core, 2 GB of RAM, and 20 GB of SSD storage. Just choose Ubuntu as the operating system. Pick your preferred server location and continue to the checkout. Before you confirm your order, you'll see the final price less than $1 per month. Keep in mind though, this entry-level VPS isn't ideal for heavy or complex workflows. It can run basic automation fine, but it's limited in CPU, RAM, and storage. For more demanding workflows, let's check out Contabo, a popular VPS provider used by companies worldwide. They offer a powerful VPS for under $5 per month. If you commit to a 12-month plan, you even get an extra 10% off. With this plan, you get a serious upgrade. 4 vCPU cores, 4 GB of RAM, and 200 GB of SSD storage, all for less than $5. If storage is your priority, they also offer an alternative plan. 600 GB SSD, 2 vCPU cores, and 2 GB of RAM, same price, more space. Once you choose your VPS, select Ubuntu as the OS, and take note of your login credentials during setup. Contabo gives you a root username, and you'll set your own password to access the server remotely. After purchasing your VPS, Contabo will send you an email with all the access credentials. Or you can simply log into your Contabo dashboard and head to the VPS control panel to find your server's IP address. Before we connect to the VPS, I want to quickly mention a few other popular cloud providers you might want to explore, like DigitalOcean, Vultr, Google Cloud Platform, Amazon AWS, or Microsoft Azure. All of them offer VPS hosting and usually provide free trial credits, ranging from $100 to $300 for 1 to 3 months. These platforms are widely used and very reliable, but once the trial ends, the cost for similar hardware can be significantly higher than Contabo. I just wanted to mention them in case you want to use one of those instead. And good news, everything we cover in this video applies to any of these providers. If you want to try one, you'll find links in the video description. Alright, let's get back to our Contabo VPS. Now, let's connect to the VPS using SSH. It's one of the easiest ways to log in. Open your terminal and type the SSH command like this. SSH root at your IP address, then enter the password you set during setup, and just like that, you're in. We now have full access to the remote server, ready to install and run n8n. Now that we're inside the VPS, let's install n8n with just one command. To make things simple, I've already prepared a script for you on the 02 launch GitHub repo. This script automates everything, just like we did in the local Docker setup, but without using a graphical user interface. Here's what it does behind the scenes. Installs Docker. Creates a data folder to store your workflows. We set up the environment variables and use the official n8n image to launch the container. All handled by a Docker compose file inside the script. This compose file defines everything the container needs. The n8n image, port mapping, the volume for saving workflow data, and all the required environment variables. It even defaults to port 80, so you can access n8n directly via your server's IP address. No port number needed. This setup is exactly the same as what we did with Docker Desktop when hosting n8n locally. Now it's time to run the install script. Click the raw button on GitHub to copy the direct URL of the script file. Then, head back to your terminal and run this command to download and execute it in one step. After launching the command, wait a few moments. Once it's done, you'll see a success message. And just like that, n8n is live on your VPS. Now that n8n is running, you can open your browser and go to your VPS's IP address. You'll see the n8n interface ready to go. From here, just create your account, and you're all set to start building workflows. But if you want to integrate with services like Gmail, YouTube, or Telegram, there's one more thing you need. These services don't allow connections to raw IP addresses. You'll need a domain name to make those integrations work, just like we explained in the local setup video. You can find a link in the description below to watch it. To solve that, we'll use ngrok to give your n8n instance a secure public domain. First, head over to ngrok.com and create a free account. Once you're in the dashboard, claim your custom domain. This will be the public URL n8n uses for integrations. Next, we'll run a script to connect that domain to your VPS. But before running it, let's take a quick look at what the script actually does. It works just like the local setup we did before, just automated for VPS. Here's what the script does behind the scenes. Downloads and installs the ngrok CLI, adds your auth token to link the CLI to your ngrok account. Starts ngrok on port 80, so it tunnels straight to your running n8n instance, and attaches your custom domain to the IP address. To run the script, click the raw button to get the direct URL. Back in your VPS terminal, use this command to fetch and execute the script. After a moment, the script will prompt you to enter your ngrok auth token and your custom domain. Now, let's grab your auth token and custom domain from the ngrok dashboard, then paste in both values. Once that's done, ngrok will automatically link your domain to port 80 on your VPS, and your secure public n8n URL will be live. Since port 80 is the default for HTTP traffic, your ngrok domain will automatically redirect to your n8n instance. No need to type a port number in the URL. Very clean and ready for API integrations. And just like that, you've got n8n running on a VPS, accessible through a secure custom domain. 24/7, hands-off, and production ready. No need to keep your computer running. No worrying about power outages or internet drops. And best of all, it's running for less than $5 a month. From here, you can start building powerful automations, integrate with any external services, and scale up your workflows as needed. If this helped you set up your own VPS-hosted n8n instance, drop a like, subscribe, and let me know in the comments what you're automating next. See you in the next video. Hey everyone, in this video, I'm going to show you how to update n8n to the latest version, whether you're running it on your local machine or a VPS. All using Docker, and the best part, you'll keep all your data intact, and do it with just one simple command. Let's dive in. Let's start by confirming what version of n8n we're currently running. We'll open up our n8n instance that's already running on the VPS. At the bottom of the interface, you might see a message telling you a new version is available. This is our cue to update. Alright, now that we've confirmed there's a new version, let's jump into our VPS to start the update process. We log into the VPS using SSH, just like we did when we first set things up. Now let's make sure we're in the right folder, the one that holds our docker compose.yml file. We run ls to list the contents of the current directory. And, yep, here's our compose file. This file defines how n8n is currently running, including volumes, ports, and data paths. Before we update anything, let's take a quick look at what this file is doing and why it's important. This file is set to pull and launch the latest available version of n8n when it was first created. It also defines a volume, which is where all your workflows and credentials are stored. That's what ensures your data isn't lost. So if we rerun this file with a new image, n8n will be updated. But the data stays exactly where it is. Alright, before we update, make sure your terminal is in the correct folder. The compose.yml file needs to be in the current working directory. In our case, that's the root folder of the VPS, where we originally set up n8n. Once that's confirmed, now let's actually download the latest version of n8n so we can launch it with this setup. This command reaches out to Docker Hub and downloads the newest version of the n8n image. But don't worry, it doesn't restart anything yet. Next, we'll shut down the current container and restart it with the updated version. This command stops and removes the old container that was running the previous version of n8n. So right now, if you try to access n8n, it won't load because we just removed the running instance. But no worries. Next, we'll run this command to create a new container using the latest n8n image we just pulled. It's like swapping out the engine, but keeping the exact same hard drive. Your data stays right where it is, and n8n boots up fresh with the latest features. Back in your browser, just refresh the page, and boom! n8n is now running the latest version, and all your workflows, credentials, and settings are exactly as you left them. Safe, simple, and updated. And here is a quick pro tip. In the future, once you pulled the latest n8n image, you can combine all steps into a single command like this. Super clean, and it brings your setup back online using the latest version with all your data preserved. Alright, we've just updated n8n on our VPS setup. Now let's move on to updating n8n locally using Docker Desktop. We'll begin by launching the n8n container from Docker Desktop. Once it's running, open your browser and access n8n locally. Just like before, we can scroll down and see the current version. And there's that little notification letting us know a new update is available. Now go back to Docker Desktop and open the n8n container details. Since we didn't use a compose.yml file for the local setup, everything was configured directly inside Docker. To make sure we preserve all our settings when updating, go to the Inspect tab. Here you can view all the environment variables that were used in the original setup. Next, we open the Docker desktop terminal. Just like we did on the VPS, we need to stop and remove the existing container before starting the updated one. This time, the command will be a bit different, since we are not using Docker Compose, and there is no YML file to define our setup. Instead, we'll recreate the container using a full Docker run command. You can copy the command from the video description. Make sure to give the container a name and use the same folder on your machine that holds the old n8n. Map it to this folder inside the Docker container and reuse the same environment variables from before. Once everything is filled in, run the command. This pulls the latest n8n image and starts a brand new container using your existing data. Now head back to your browser and refresh the page. And just like that, all our previous data, workflows, and credentials are still intact. And n8n is now running locally with the latest version, ready to go. If this video helped you, give it a like. Subscribe for more tutorials on AI agents, automation, and self-hosted tools. And drop a comment if you have questions or want help with your setup. And don't forget, all the resources, scripts, and help are waiting for you in the 02 launch community on School. Join for free and start building with us. Until next time, build smart, automate better, and I'll see you in the next one. Alright, in today's video, we're diving into how to host n8n in the cloud completely free. No need for nDrock tunnels, no need to buy a custom domain, and no more errors from local or VPS hosting. This setup is cloud-based, secure, and only takes a few clicks. Let's get started. First, head over to the lesson page where you found this video. There, you'll find a link to a platform called Claw. To sign up, you only need a Gmail or GitHub account. Easy, right? But here's a cool trick. If your GitHub account is older than 6 months, you'll unlock a recurring monthly benefit. That's a free $5 credit every single month. That's more than enough to host n8n indefinitely, for free. So go ahead and log in using your GitHub account. Once you're in, the platform will ask you to select a server region. Pick the one closest to you. This helps with speed and performance. Then give your workspace a name. You can call it something simple like n8n. After creating your workspace, you'll land on the dashboard. You'll notice several sections here. But first, let's take a quick look at the available pricing plans. Their pricing is actually pretty generous. And to keep things free, we'll be sticking with the free plan. This gives us access to a lightweight VPS. Not super powerful, but perfect for personal workflows and testing. If you ever need more power for complex workflows or production use, you can always upgrade to a paid plan or switch to a different VPS provider. Alright, back to the dashboard. Now head over to the App Store section. Here you'll find a variety of templates, but we're only interested in one, which is n8n. You'll see that hosting n8n on this platform only costs $0.110 per day, and it's automatically covered by your monthly $5 credit. That means with the recurring benefit, you can host n8n forever at zero cost. Let's go ahead and click Deploy App. It may take a moment, just wait for the loading to finish. The app will now spin up, and you'll see it's being assigned a public address. Once it's done, you'll have access to a secure, publicly accessible HTTPS endpoint, ready to go. And just like that, your n8n instance is live, hosted in the cloud for free. Now let's head back into the app settings. Under the Advanced Configuration tab, you can tweak environment variables for n8n. If you make any changes here, make sure to restart the app so they take effect. And finally, to keep track of your usage and credits, just open the Plan section. Here, you'll see your monthly balance, including the free $5 credit being applied. Pretty cool, right? So now you've got n8n running in the cloud for free with a secure HTTPS endpoint and no need for tunnels or domains. This setup is perfect for learning, prototyping, or running personal workflows without spending a dime. This is just one of many AI video we explore inside the 02 Launch Premium community, where we take the most advanced tools out there and make them simple, accessible, and actionable for creators, developers, and automation enthusiasts. Inside the community, you'll get access to unlimited premium APIs, including GPT 4.1, realistic text-to-speech voices, speech-to-text transcription, text-to-image, with Flux and OpenAI's Vision API, and a whole lot more. It's a full-stack AI toolkit ready to plug into your projects without limits. If you found this tutorial helpful, make sure to check out the rest of the lessons in the AI video series. And if you're ready to take your AI automation skills to the next level, join us inside the community and unlock everything: the tools, the templates, the support, and the momentum. Your next automation breakthrough might just be one lesson away.